Hey guys, eMachine03 here, and welcome back to a brand new video going over a math problem from anime. Today's problem comes from a show called Assassination Classroom. Like my last video, I haven't actually watched any of this show, but apparently it's good. Before we start, I'm going to attach a spoiler warning to this video because apparently this problem plays a major role in the plot of the ending of Season 2. I'm not going to be talking in depth about the plot of what actually happens in the show, but I will be stating which solution was correct in the show and which wasn't, among other things. Also, they apparently go over the problem in a cool way in the show. So if you want your first experience with it to be from the show itself, maybe finish Assassination Classroom first and come back when you're done. With that out of the way, let's get started with this problem. So as far as I can tell, there's some sort of competition going on where these two people need to solve some math problem. And unfortunately for us, it's a word problem. You might have thought normal word problems were bad enough, but now we have to try to understand a description that has been translated from Japanese. I found a few different translations online, and while they were all somewhat different, they had the same general idea. Here's the one that I liked the most. Yeah, if you want to read that, you can go back and pause, but I'm just going to explain in my own words. Basically, imagine you have a bunch of cubes arranged in a structure like this. This is what a crystalline structure of atoms might look like. Let's move over to one cube for now from this structure. At each vertex of the cubes, you have an atom, represented in this model by a red dot. Additionally, suppose you have one atom at the center of each cube. In total, each cube has 9 atoms. Let's call the atom at the center of the cube A0 or A0, or whatever you want to say. We are given in the problem description that one side of the cube, which would be a yellow cylinder in this model, has a length of A, which is just a variable. Using just this information, we need to find the volume of the region of the cube where every point contained within the region is closer to the atom A0 than any other atom. Simple, right? No? Well, hopefully I can help you understand by going through 2 possible solutions. First, I have a simpler and more theoretical solution. Remember how I mentioned that these cubes represent atoms arranged in a crystalline structure? This solution uses that idea. When I explained the problem, if you remember, I said something about points closest to A0, but this can also be interpreted in this problem as finding the volume of a single atom within the crystalline structure, and we will call the volume of this atom B. Additionally, from the problem description, we know that every atom in the crystal is the same exact type of atom, meaning that every atom has the same volume. Keep that in mind, it'll be important later. Earlier, I said that each cube has an atom at its corner. When I said this, though, we were just zoomed in on one cube. In reality, each vertex atom rests at the corner of 8 different cubes all at once. If you assume that the atom is spherical, then it is easy to see from this that each of these 8 cubes contains 1/8 of the atom's total volume. Let's go back to a single cube. This cube has 8 corners with an atom present, so 8 separate times a corner atom occupies an amount of space within this cube equivalent to 1/8 of the atom's volume. 8 times 1/8 is 1, so the total amount of the cube's volume that is occupied by atoms besides the central atom is equal to B, which is the volume of one atom. Logically, we can assume that the rest of the cube's volume that is not occupied by corner atoms is occupied by the central atom, whose volume is also B since every atom has the same volume. Also, recall that the volume of a cube is the side length cubed. Using this fact, we can set up a simple equation and solve for b, allowing us to find that the volume of b is equal to the side length cubed divided by 2. And that's it. That's the right answer. Now, this is a valid solution, and it is in fact adapted from the right solution presented in the anime. I don't know if it's just me though, but something just feels off about this solution. There's too much abstract reasoning and not enough equations for my liking. So, I'll present another solution that combines my personal reasoning with some ideas from a few different Stack Overflow posts. In this solution, we're going to follow my description of the problem by trying to find the volume of the region of points that are closest to the central atom. To make this easier to approach, let's split the atom. No, not like that. What I meant is, let's divide the cube into 8 subcubes formed between the central atom and each corner atom. Then, let's focus on just one of these subcubes. I think it's pretty reasonable to assume that every point within the subcube is either closest to the central atom or the corner atom, and not any of the other atoms present within the crystal lattice. Now, for any point within this cube, how can we compare its distance to the central atom with its distance to the corner atom? That's right, the three-dimensional distance formula using the x, y, and z axes. Using this formula, I found the equation for a plane that basically serves as a turning point for the points within this cube. Below this plane, all the points are closer to the central atom, while above the plane, the points are closer to the corner atom. At this point, all we would need to do is find the volume of the polyhedron formed by the intersection of the plane with the cube, and verify that its volume is half of the subcube's total volume. But this is where I sort of ran into a problem. For some reason, it's really tedious to find the volume of a polyhedron. Of course, it could be an interesting calculus exercise, and I might make a video later where I actually solve this, but I'm going to be real here. I really don't want to have to solve this mess. So for now, I'm going to take the approach that others took online and just simply assume that half of the points within this cube are closest to the central atom and half are closest to the corner atom. So with this assumption, we can extend this finding to the other subcubes, allowing us to conclude that the volume of the cube that contains points that are closest to the central atom is equal to half of the cube's total volume. In other words, b equals a cubed divided by 2, using the notation from earlier. And this is the value that we found in the first solution. From what I can tell, this solution seems like it's similar to the wrong solution that was presented in Assassination Classroom, but the geometry in the solution from the anime is somehow even more convoluted than my solution. I honestly don't really understand what they were trying to get at with this, but oh well. Anyways, the person who proposed this solution in the anime got points taken off of their solution, so maybe that's the point. So, that's going to do it for this problem. I hope you guys enjoyed and maybe even learned something new. And yes, I made all the 3D models for this video and the animations myself in Blender. If you look closely, you can tell that the models are kind of sloppy, but hey, that's why they're just models. A lot of this problem revolves around spatial visualization, which is a pretty difficult skill. So I thought that modeling the problem like this might make it easier to grasp. And it also made a pretty good thumbnail as well. Before this video ends, I just wanted to say I really appreciated the support on my last video about the My Hero Academia calculus problem. It's by far the most views I've ever gotten on a video. I'm just really glad there's a lot of people out there who are enjoying what I'm putting out and are as interested in math as I am. If you haven't seen my previous video yet and are craving more content about math and anime, I'll put a card here so you can click that and check it out. As for future uploads, I have a few more math video ideas in the pipeline, but I'll also be making some videos about other nerdy concepts like technology and video games. Just wanted to let you all know in case you see something a little different in your feed in the near future. Anyways, as always, I'm eMachino03, and I'll see you guys later.